Here, I'm about to record. And then what we're going to do is basically I'm going to have this PDF open, which you'll see in just a second. Share. And we're just going to share the exam one. And then if we need to change what I'm sharing, then that will happen. And we're just going to walk through the exam and we're going to go over a lot of the problems. So it's going to be pretty, and so if you understand how these questions and how we're getting these answers, then you're going to be in pretty good shape for the actual exam. If you have a Monday lab, you do not have an exam tomorrow. That is going to be next Monday. All right. So first thing you'll note is that there's a 105 points on this exam. This should be the case on the actual exam itself. While the actual exam is out of 100 points, while you can only get a score, but while basically your exam score is out of 100, you could get up to 5 extra credit points. Or another way to look at it is you've got 5 points as a freebie to miss. So you can still get a 90, which is an A, if you miss 15 points worth of material. And those of you coming from possibly not the US, that does sound like quite a lot, you know, in terms of like quite a high score, but it is the way things happen in the US. Like I said, practice exam is much, 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 much longer and harder than the actual exam. Typically, we're able to go through this entire practice exam, though, in an hour and 20 minutes. If you want to actually time yourself, like give yourself 2 hours at least on this exam. So that would be it. The exam itself is going to be in your next lab starting on Tuesday. So it's depending on when your lab it is going to be on the 30th to the 6th. The exam will be now. Okay. The points are how much. Another thing you should know. This is all just kind of exam administrative material. The amount of space I give you is not reflective of the difficulty of the problem. The amount of points I give a problem is reflective of the difficulty of the problem. The amount of space is basically the amount of space that you might have to write. I'm a messy writer. I might do it for formatting purposes. The space does not correspond to anything other than I want to keep the exam neat and organized, and give plenty of space. You're allowed to clarify any answer you give. I have one of my best friends. He would often joke that every question is an essay question, including the multiple choice. This is because I might have a bad question, and there might be assumptions that you're making that you might want to clarify. You're also allowed to ask your TA or me for clarification. The TA should be able to contact me. Things are never as complicated as they appear, especially the map. I do not like long questions or complicated answers. There are actual hints here in this space on the actual exam. And don't leave your questions blank because I can't give you credit for blank answers. That being said, don't blindly copy from your notes onto the paper. That's just going to get mockery when we actually grade it. That being said, we won't actually know who we're mocking because the way we work is that we flip over to the exams, we don't look at the names, and we basically, one person will grade every single certain page. Like David might take page 3, I might take page 5, so the same person grades every single question so that we can be consistent in the way we're grading. That way it's going to be consistent among how it's graded. Yeah, exactly. We don't know who you are when we're grading the exam. It also helps us keep us biased because we are humans and we have bias as a result. So let's get started with this. All right, true or false? Computer science is the study of computers. This is a false. False, right? Computer science is the study of algorithms, right? Computer science is the study of algorithms. And if you misspell algorithms, whatever, okay, I'll figure it out. All right, true or false? Alan Turing is often considered to be the first programmer. That is also a false. Okay. Alan Turing is often considered to be the first programmer. That is false. That is answered by the next question. Who is Ada Lovelace and why is she an important figure? Ada Lovelace was a noble Lord Byron's daughter. She lived in the 1800s. translated Babbage's paper, added notes to it on his machine, often considered the first programmer. Okay. For those of you here, I will give you a hint for, so the first page of the actual exam will look something like this, where there will be a question that's approximately like this one. Another one on this one, I might give, I might would say for this question, review assignment 1. Whatever you did for assignment 1 will give you the answer here. Okay. Whatever person you did, and you're like, well, but we have a different person for assignment 1. Yeah, that's not good. That's fine. Review what you did for assignment 1, or just remember these facts. That's yeah. Whoever you did, it was fine as long as you didn't make anything up. Anyway, another thing that I would know, a question is, does anybody know where the word algorithm came from? Anybody remember that one? It's the Latinization of a Persian mathematician who was whose name was who was Algorithmi or Al-Khwarizmi. And I'm going to butcher this. Al-Khwarizmi. But if you look up Algorithmi or algorithm, you'll be able to look up the name. Refer back to the first lecture, but that's where it comes from. It comes from the Latinized name of a Persian mathematician. All right. So next page. On the actual exam, you see that there's 10 of these math questions here. 10 of these math questions here. On the actual exam, there will be 5 math questions, each worth 2 points, rather than 10 worth one apiece, right? And that makes more sense for the actual exam. And then because we'll have plenty of space, these questions over here will be moved to this page, right? So again, this is what I mean by the exam's a very good facsimile of this question. So this is basically an order of operations kind of question, okay? And again, the math is never really too hard, okay? So this one basically is asking our questions, do we know our order of operation? So 2 times 3 is 6. So this becomes 6, right? 6 divided by 6 becomes 1, and 1 times 100 becomes 100. Make sense? So what we do not do is do 6 divided by 600, because it's not a fraction kind of thing going on there. It's times, divide, times, and those all have the same level of precedence. Okay, this one mod 2 plus 3 mod 2. And you can always double check these by plugging them into the computer. When you're checking your answers, not when you're taking the exam, obviously. 1 mod 2 plus 3 mod 2. Modulus, right? It's PEMDAS. And you can remember M for modulus as well, right? M for multiply, M for modulus, because it has the same level of precedence. So we do the modulo operation before we add or subtract. Okay? So 1 mod 2, that's asking 1 divided by 2, right? If we do 1 divided by 2, what is that? That's going to be 0, remainder 1. So this is 1. 3 mod 1. Sorry, 3 mod 2. That's also 1. The remainder of an odd number divided by 2 is always going to be 1. So it's 1 plus 1, which is 2. This one, I honestly don't know why I put this one. I put this one in. Not all of them are hard, but -1 plus -10.5, just reminding you negative numbers exist, I believe. And also that you can convert. Did I make this multiple choice? I forget. Let me double check. Do you remember off the top of your head if I made that section multiple choice? I feel like I converted most of these over to multiple choice.
You did for a lot of, yeah, you did. So there's
Yep.
going to be a part where it's multiple. Yeah, that part's going to be multiple choice.
Well, that's going to have to come off in the recording. Oh well. So yes, these all got converted to multiple choice. Yeah,
So
those
there's a
all.
20. So there's a quarter chance the right answer is in front of you for each of these answers.
Yep, all these. Yeah, so these got converted to multiple choice. For the first ones because I want just to help speed up our grading. Um, multiple choice questions are actually some of the hardest ones to write, but they make it easy to they're the easiest to grade. All right, again, over here with order of operations. Multiplication takes precedence, so we do this one, 6. 4 plus 5 is 9. So 9 minus 6 is 3. Right? It's not 4 plus 5 minus 3 times 2. It is 6, and it is 4 plus 5 minus 6. All right. So this is what I mean by the math is never. So we're starting to get into the stuff where I say the math is never as hard as it seems, right? 0 times, and yes, we have parentheses here, which means this has to happen first, but it does not matter because it's all multiplied by 0. And so if we multiply by 0, we just get a big fat 0, which means this is negative 1.0. Make sense? So use those kind of simplifications to your advantage, even here. 2 times 4 minus 20. 8 minus 20, negative 12. All right, now we're getting into now these last four are kind of the trickier ones, okay? These are probably the most important ones here. 7 divided by 3. So again, 7 divided by 3, that's, you might want to go, that's 3.333. But remember, double divide, the divide symbol means integer division, right? So it's 7 divided by 3, 3 goes in twice. So I was wrong when I was writing 3.33. It's 2, it would have been 2.3333, but we don't care about that 0.333. It's 2. Okay, it's just 2. 7 divided by 3, the quotient is 2. And then we'd have a remainder of 1. So this is 2. Plus, and then 2 times 3, 6. Everybody got that so far? Okay. 4 mod 2 times 3. Again, when we are talking about, again, PEMDAS, okay, basically, this is a group, okay, and this is a group. Multiplication doesn't need to happen before division. Similarly, addition doesn't happen before subtraction. They have the same precedence. They occur left to right. So here, 4 mod 2. What is 4 divided by 2? What's the remainder? It's 2. Is there a remainder? No. So this becomes 0. 0 times whatever, I don't even care anymore. It's 0. All right. Now, let's go ahead and do big number divide, even bigger number, right? The big number divided by an even bigger number. Okay, so it doesn't really matter at this point. 52482, divide, 24478, 198. That's just apparently my monthly test of my alarms. Okay, 52482. Doesn't matter what this number is. It's a small number, right? This is a small number. Okay, it's a small number. Divide by big number. Doesn't matter. Okay, that's always going to be 0. Make sense? Doesn't matter because there's always just all this is going to be just big remainder. Sorry, it's just going to be left as the remainder. Similarly, if I were the other kind of variation I love on this problem is to do something like this, which is I would do, rather than do divide, I would do mod. I will go back to H in just a second. And if it's small number, mod big number, right? If this number is that much bigger, then that's just going to become 5248 because the entire thing is going to be the remainder. For H, again, it was 4 mod 2 times 3. And so what we did is we went left to right because it's all multiplication operations or division operations. 4 mod 2, the remainder of 4 after we divide by 2 would be 0 because 4 is evenly divisible by 2. Okay, so this would be 0 times 3 becomes 0. Big number divided by small number, that's just normal division, right? Except you don't care about the, except it's just normal 4th grade division, right? This is just normal 4th grade division. So basically, if you got something like 21 divided by 4, right? Just think about it in terms of how you would do that in 4th grade or whatever, right? Which is you'd put 5, remainder 1. And so divide. So this divide gives you this, and modulo gives you this part. Make sense? All right, last problem. 10 times 2. This is exponentiation, right? So that gives us 100.0, I believe. I believe it automatically converts to a float, and then times 2, that gives us 200. All right. All right. Now for problems like this one up over here, like 5, there will be a number of problems like this. I highly recommend you do exactly what I'm doing. By that I don't mean start screencasting the exam. That's probably not kosher. What I mean by that is you want to take a pencil or a pen and then like write and cross out stuff. All right. So we've got x is equal to 7, y is equal to 8, z is equal to -3. And there's basically 2 ways you can write this down. You can have x, y, and z over here and just keep your numbers over here and then change them as they change, or you can just basically cross them out as you go through. It depends on how messy you like to make your exam, okay? And when in doubt, if you just want to make sure I see the answer, just circle it, you know? So x is equal to, so over here we have x is equal to x plus 1. So we've already set these variables up. X is equal to x plus 1. So that means that we would get x is equal to, so remember, these equal signs mean we take what's on the right and store it on the left. So here we would take the value of x, which is 7, add 1 to it to get 8, and then we're going to store that in x. So that means that x's value is now 8. Okay, now y's value is going to be x plus y plus z. So x is equal to 8, right? Because that's what we have. It's not 7, it's 8. It's 8 now. Y's value hasn't changed. It's still set to 8. And z's value is -5. Okay? 8 plus 8 plus -5. So 8 plus 8 is 16, plus -5, that's -5. So 8 plus 16 minus 5 is 11. So we store 11 here. Now we have z plus equals 1. So this is just a shorthand for saying z is equal to z plus 1. So this is probably the hardest part about this problem because instinctively when we see, aha, we increase this z's value by 1, we're going to go to 6. We're going to make them value bigger, but it's a negative number, right? This is why partial credit is a thing, by the way, because it's so easy to make silly mistakes on one part, but get everything else right. So we are big believers in partial credit. So what we have here is -5 plus 1, right? Which is the same as saying 1 minus 5, which is -4. Okay. So so again, whenever we see a variable like apple, whatever the variable is, plus equals 1, that's a shorthand for saying apple is equal to apple plus 1. Mm-hmm. Mm-hmm. All right. All right. So these next ones are true false questions. They're basically the closest we have to if else statements on the exam, okay? Which is just these true false statements. Okay? So there will be a grand total of 3 of them on the exam. And they're also a grand total of 5 points total. Okay, evaluate the following conditional expressions to true or false. So remember, so the key here is that or means that that basically one has to be true, is that basically one of two have to be true or both, right? It will it'll be true if one of the two or both are true. On the other hand, a and statement, for an and statement to be true, both sides must be true. Okay? So, and we'll get to the not in a second. Okay, true or something else. 3 is equal to 2 is what we're checking there. Okay, that's what the double equal sign means. It's asking, are these two things equal? That would be false, but honestly, it doesn't matter. It's true or whatever, right? This is basically the same logical equivalent of multiplying by 1 or multiplying by 0, depending on how you want to feel about it. True or whatever makes the entire thing true. Make sense? All right. Next, not false. A not is a flip. It flips the meaning. So, and that makes sense. And what's not false? That's a true statement. I will also accept T's here as opposed to true or false. That's perfectly fine. I'm not a stickler like that. I'm not going to nail you for points like that if you forget to capitalize true or false or do a T and F instead. Okay, we're on an exam. It's paper. It's fine. Okay, not for less than 2 and 3 3 less than 10. So let's do this first. 4 less than 2, because that's in parentheses, we do that first. 4 less than 2, that's false. Not false becomes true. True and 3 divided by 2, sorry, not 3 divided by 2, 3 less than 10 becomes true. So true and true, that is true. 32 divided by 8 is equal to 32.0 divided by 8. So this actually is one, so these two over here are, these two are interesting because they're here for different reasons. This one's here to be is because even on practice exams, I can't help but want to teach you something. And this one's over here because I'm a jerk. So this one over here, 32 divided by 8, right? 32 divided by 8, we know that's 4. And if we check the other side, 32.0 divided by 8, right? A decimal divided by a decimal number, or float divided by float, gives us 4.0, right? So the same number, just one's a float and one's an integer. Make sense? So really what this question is asking, are these two values the same? And the answer is, well, how does Python, does Python consider these two values the same? And the answer is yes, they do. Because anytime and what rule do we use to logic us into the correct answer here? And the answer is, anytime we do an operation, and an equal sign, double equals is an operation. Anytime we do an operation on an integer and a float at the same time, the integer gets converted to a float. Make sense? So to go over C again, just for a second, whoops, it's a text field. To go over C again, basically we've got these two parts. We've got the left side of the and the right side of the and, okay? Let's go ahead and try to get that a bit cleaner, right? We've got the left side and the right side of the and, okay? So left side, so the right side of the and is 3 is less than 10. This is true, okay? Now here we have not something. So not's going to flip the result of whatever we have. So 4 is less than 2. Is 4 less than 2? Is this a true statement? Yes or no? No, it is not. So this is false. But the not's going to flip we have a false, but the not's going to flip the answer. So not is going to take this false and flip it to a true. So we have the left side of the and being true and the right side of the and being true. So the entire thing is true. Similarly, this statement over here, the not false, we have not false. that flips false to the opposite value, which is true. So when question, divide gives you an integer. Divide gives you an integer. But what we're saying, and a single divide is for a float, right? For a decimal number. And what we're saying is that anytime we are mixing decimal numbers with, floating point numbers with integers, it's going to get converted to a floating point number. Make sense? Okay. Let's go ahead and erase a bit because I need room for this last one. Okay. So this one, like I said, I give this one because I'm a jerk. Okay. So we have an and statement here. Okay. And it's inside a not statement. Oof. Okay. So just simply let's look at the parentheses. We have a pair of inner parentheses here and a pair of inner parentheses here, and they're separated by an and. So let's go ahead and see. Let's go ahead and look at this first parentheses. So let's, again, PEMDAS, parentheses. Inner parentheses are over here. True or something. Again, same rule as up here. True or something will be true. So we can simplify this entire side over here to true. So now we have an and a right side. And not false or true. False or true, again, we have if we have a false statement, if any part of it is false, if any part of it is true, the entire thing is true. However, we have a not here, which is going to flip it. So it becomes false. So we have true and false. We have true and false. So true and false, that is going to become false. But we have an outer wrapper as well for a not, which is going to flip the entire thing to true. Now, this is going to be a hell of a lot harder than anything I actually put on the exam. Yes, Jabbar, that is correct. E is hell of a lot harder than anything else I would put on the exam. Also, don't psych your, this is also to put to kind of just set, David, I'll get there in a second. I'm going to just simply say, notice that all my answers here are true. Don't psych yourself out by trying to second guess what answers I put down on the exam. Okay? I am a jerk. I am the type of professor who will aptly make everything true or false just to make my job easier. Do not second guess yourself. Now, I do not believe I set all of them to true or false, but I have done so in the past. Okay, David.
Okay, we had a couple questions about the integer division.
Yes.
Looks like Cam the man was saying that when you do the integer division, it always equals an integer or equals a float. There's some confusion along that line.
Let's go ahead and take a look at idle. We're gonna boot up idle, and we're gonna, yep. False is opposite. Sorry, not is opposite day, right? If I say not true over here, boom, false. If I say not 3 less than 2. Right, that's a false statement. True, right? 3 is less than 2. That's normally a true statement. Sorry, false statement. But because I threw a not in there, it just takes that and converts it. Okay, now as let's do some easy math here. 8 divided by 2 with a single divide. Okay, doesn't matter what I put in there. Okay, if it's floats or integers, if I put a single divide, I'm always going to get a float out. Okay, 8.0 divided by 2.0, I'm always going to get a float. Make sense? Now, the only confusion is going to come with the double divide. Obviously, if I put an int and an int, I'm going to get an int because this is integer division. But what happens if I do this? Okay, and this is not something I think I test on the exam, but it gives you anytime. But there you go. Like I said, anytime we interact with a floating point number, that's going to give you a floating point answer. Okay. And that does get annoying because 9 divided by 2, 9 divide And this is the reason I don't test this particular interaction on the exam. 9, I'll test what double divide does, but like something like this, I don't test because it looks so icky to me. Yeah, exactly. Like, David, have you ever used this into your extensive amount of programming? Because you do a lot more practical than I do. I do a lot of theoretical. David does a lot more practical.
Yeah, that's the part of an IST major. We when we use this kind of stuff, sometimes some things break and don't add together, and this is usually the part why it doesn't.
Yeah, this is not something we ever should see. But why, right? I don't try to do bad programming practices like that. All right, let's keep going on to this one. So string slice and range. So, this part is again just kind of like a range function, right? Kind of like a range function. Just how range can have up to 3 parts: start, stop, and step. Okay, our slices is made up of 3 parts. It is start, colon, stop, and colon, step. And either conveniently or inconveniently, they all start with the same 2 letters, start, stop, step. Okay. So, and we have, so this section again is going to be on the exam and will be multiple choice again. Okay. So again, it will be something like A is equal to this, B is equal to this, and then I give you slices, just like just like I did on the other one. Okay, so let me go ahead and erase that information I just put up, because this is what I like to do anytime I deal with this kind of nasty stuff on an exam, because I like reducing my mental load. Okay, do whatever you can to reduce your mental load on an exam. So I write down the indexes: 3, 4, 5, 6, 7, 8. What if I don't have enough room? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Make sense? Like that? So just write something down so you can get the space earlier. But if you can, just like, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3. There we go. And that just will help me a lot. Okay. Okay. So that means that when I ask what is at index 3 of A, I can just go 0, 1, 2, 3. I don't have to count. I can just look at the 3 label and say, aha, A is there, right? The letter A. And if you forget to put your quotation marks, I don't care. It's fine. It's not going to matter for this one. Okay, A from 3 to 8. Okay, so this is the start to the stop. Up to, but not including the stop. So up to, but not including 8. So this gives me apple. Make sense? So this goes up to, but does not include index 8 of A. We don't care about the letters here because it's not asking about B. It's asking about A. Okay. Whoops. Come on. No. Okay. Hey, what you doing? There we go. All right. Now we've got B -2, A, and then this nonsense over here. Right. Okay. I remember doing this nonsense. I know this answer. Okay. So this part over here, so again, this is patented Professor Rosen's being annoying on the practice exam. Again, I'm not as annoying about these things on the actual exam. So in other languages, as I've mentioned, a negative index is invalid, right? In other languages, but Python's like, yeah, I love it. Okay, so the negative index is basically go from the other end. So this is -1 so this is -1, -2, -3. Make sense? So B -2 is the second from the back. In other words, this is B. Okay. Next is A3, but we've already solved that one. It's index 3 from A. Okay. Next is, okay, this one's weird. Okay. So when you have start and stop and you have step, right? We have X, Y, and Z. But here's the fun part. You can leave stuff out to imply things. Such as you can do something like this. Let's go ahead. So let me actually go and bring up the window because I'm not pressed for time here. If you have to duck out at some point, just know that I'll upload the recording. Okay. So let's go ahead and look at this thing over here again. I'm going to go ahead and say A is equal to Apple. I'll be uploading this to our Windows playlist, and then I'll send out an announcement as well. Okay, with a link of it. So A is equal to Apple. A, right? I do A. No. TOSIF, that is something that is reserved for CIS 3223 and only specific questions in 3223 where things are specifically like prime number, like adjacent to prime numbers and things like that, where basically there are hacks where you can calculate that, but those hacks only work for specific numbers, so you don't have to worry about that. Okay. Those are those are questions I'll ask in 3223, but not those kind, not that specific one because it will work. The math has to work. Okay. Anyway, A2, right? Index 2 is P. So a slice, first off, if I leave off the beginning and ending of a slice, it just simply gets the whole thing. If I leave off the beginning, it says just start at the beginning. And if I leave off the stopping point, it says just go to the end. Whatever the logical end is. So if I say, hey, from index 2 to the end, it's like that. Make sense? Similarly, if I do this and just leave off the step, it's going to imply -1. So imply 1. It's going to imply just, normal left to right. So here's the fun part. Beginning and ending can be implied and inferred based off of what the other arguments are. So here I want to say, I want to go from the beginning from an ending, but I want to use -1. So it figures out, oh, well, that only makes sense if you want to go from the back. So similarly, A from, say, index 3 to the end by going down will go from LPPA. Okay, so this, all right. So that means so this part, A from index 1, so that's an N over here, to the ending of this slice. What is the ending? And going by -1. So going in reverse. So in other words, from index 1 through the beginning. So that is NA. But this thing gets multiplied by 2. What does that mean when we multiply a string by 2? It's replication. So the answer is banana. Okay. So, and again, these are all going to be multiple choice. All right. And now this last one says, from the beginning to the end, starting at index 1, right? Sorry, from index 1 all the way through the end. So start at index 1, which is here, go all the way to the end, and go by 2s. Go by every other one. And so this one, in other words, we are looking at every other character. Make sense? And characters do include spaces. So if we write it out, it will be HIDDEN. Say, right? HIDDEN space MESSAGE. There you go. Hidden message. These are typically tougher. So these are tougher than what I would give on the exam for two reasons. One, because there's just a lot going on in one question. I like to be my questions on the actual exam to be a bit more targeted. And with D, this is a great practice problem because it's so long, but on the exam, that is extremely long for an actual exam. I need to be respectful of the time it might take. All right. So you will get some amount of code writing, but a very minimal amount of code writing. If you've taken a look at the practice exam, we really don't want you to write code at this point. There's a lot of what does this code do? Okay. So complete this function. The function takes in the string, the argument text, and prints the string in reverse. Now there's like 1.5 million ways to do this one. There's just so many ways to do this one. And the reason I mention that is I don't care which one you do. You can do it in 1 line, you can do it in 5. I don't care. Right? So, and again, we're just simply taking this text. This text could be anything. It could be any string, but it's going to be printing it in reverse. So the way we do this is the answer is not this, by the way. The answer is not print TXET. That's not the answer. We've seen that before. And it hurts my soul. But to print this in reverse, basically there's a couple ways to do this. There is the slice way. And then so basically there's two categories. There's slice and then there's for loops. Okay. So let's go. We just did slices. So we kind of actually I kind of already passed you the answer for the slice, and that's the one, and this is the one-liner for how to do it, which is that a slice you can give you the answer by doing this. From the beginning to the end, -1. But this is like elite hack stuff. So I don't really expect to see this as the answer. But I want that there for completeness sake. No, typically for the answer, what we want to see is a for loop. Now there's a couple different ways to do this for loop. Okay. Generally speaking, a for loop has 2 ways to do it, right? If we go with a for loop, we can go by letter or we can go by index. Yeah, Sung. Yeah, okay, you already got that. So we can go by letter or we can go by index. We'll go ahead and do by letter first, which is just simply saying like this. For letter in text, right? For thing in collection, for letter in text. And honestly, it doesn't matter. We could do for L in text. We could do for S in text. We could do whatever. It doesn't matter what that variable name is. I like letter because it's very explicit. Okay, so we kind of already know how we would do a for loop to print this out in order. For letter in text, I would just simply do print letter, and this would print out every letter one at a time on each line. So that's close. It's in the wrong order and it's line by line, but it's giving me something. I know I can do that something. So if I want to get it all on the same line, let's think about it. How could I do this? I could create something called an output, another variable out here, and that would hold an empty string. And rather than printing over here my letter, what I could do is I could then say output is equal to output plus the letter and print text. And this would still get me, okay, for the so if my input was hello, this would basically say output would be H, then we add E to the end of it, then we'd add L to the end of that, then we'd add L to that end of it, then we'd add O to the end of that. So I'd still be printing it out in order. So how do I get it reversed? Well, this is kind of a weird one, but like I've got this output. I'm adding H to the end, E to the end, L to the end, L to the end, O to the end. What I would really like is that if I could add it to the beginning, H to the beginning, then E to the beginning, then L to the beginning, then L to the beginning, then O. Make sense? Okay, so how do I do that? Okay, and the answer is we flip this around. Not the output equals, but the right side of that. And we say letter, we want to add the letter to the beginning of our output. So we do that. Letter plus output. And now we'll get the correct answer. Okay. And if you want, you can try these things for yourself. I don't know why I'm not typing this up and subjecting you to my horrible handwriting. I guess it's just because I bought this Wacom tablet, so Professor Rosen's going to use the Wacom tablet. The best pre-COVID purchase ever. Okay. The other way to do this is we are going to do our for loop with the indexes. So same kind of idea here, right? Except what we'll do is we'll say output is equal to, right? So this is a completely separate answer. Output is equal to same thing. We're going to print our output at the end. What happens if you forget to print it, but you get everything else right? Oh, right. What if you forget to do this? What if you did make the oopsie like I did? That the answer is that I'll probably miss it. And at worst case scenario, you're going to get docked maybe a point at most. But honestly, as you can see, I made a mistake there. It's fine. What I care about is the problem solving process. Were you able to get that for loop or something? Right. There's our output. There's our output. For index in range length, for how big this string is, text. And this is very similar. I could just simply do letter is equal to, I could do the exact same thing as I was doing. I would just simply do letter is equal to text index. Thank you. Thank you, David. And then do the exact same thing. Or since I'm already using the range function, I can instead change up slightly what I'm doing over here. Range from length of text -1, which is the last index. So this thing is, say it's hello, this thing is 5 long, so we'd want to start at index 4. Go down to, but don't include, we want to go down to 0 and include it. So that means -1 over here. And then we're going to go down, so -1. Whoops. Yeah, let's pick up the pace here. But I do want to answer questions. So letter is equal to text. And then we can just simply do output. Yeah, then we can just simply skip this entire step over here and do output plus equals text index. Basically, that would go index by index in reverse. So you can see we have 3 very different ways to solve this problem. Okay. All right. So this part, turtle. There's going to be a lot of turtle on this exam. There's going to be a question pretty much exactly like this pair over here, where basically I ask you, here's some code. Can you draw it, roughly speaking? And then what's the change I just made? Okay, a couple of things I want to do to assuage some nerves here. First off, I don't need any protractors. So your angles are going to be you're going to be given essentially just 2 angles on turns. You're going to be given 90-degree angles and you're going to be given 45-degree angles. What if I accidentally do something like this as a 45-degree angle? I don't care, right? If there's only 2 angles, 90 degrees and 45 degrees, so I'll be able to figure it out. Got it? So basically you have there's only a couple of turtle commands we really care about that you're going to be dealing with in this. First off, you've got forward and backward, which are going to be relative amounts, right? You kind of choose what that distance is. And don't worry about, basically a lot of things are going to be equidistant, so as you'll see. So basically you'll either have to choose a distance and then just choose, and then at most have to make a decision about what's half that distance. It's fine. So you go forward and backwards, you have left and right. which turns the turtle left and right. You have your ups and downs, which basically says up, I'm not going to draw. And down says, I'm going to put the pen down to the paper and draw. Okay. Pen up, pen down. Okay. And then finally, we have one more command, which I use called stamp, which is the turtle doing the belly flop. Okay. And that's so that I can do things that have dots for patterns. Okay. As an answer. So 7 commands total for the turtle. Okay. So import turtle, turtle.turtle, and then we give a function just like the problems we have in problem in our labs form 5. That's no, I'm busy. You just called your kid Andrew. You did. All right. Question Ziggy. So basically, this is going to be running on Bob for some length, which is going to be 5. So in other words, it's going to do this following thing 5 times. Okay. Now, by default, the turtle is basically starting out in this direction. So Bob right 45, which means now the turtle's facing this direction. So forward 10, whatever 10 is, left 90 degrees. So it's currently facing this direction. Turning left 90 degrees would turn it this way. Okay, so boom, 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 forward 10. Right, he's turned this way. Basically go down the same amount, go up the same amount he went down, right? And then right 45, which means he's going to be facing this way again, this way again. So now if we go forward with this, he's going to turn right 45 degrees. So he's facing this way again. This one again. Go forward 10. Left to go 90 degrees. Here we go. And then right to be facing the same way. So we've just done one of these. We've done 2 of these now. So it's going to be 1, 2, 3, 4, 5. This is a correct answer. Okay. Notice how messy it is, right? You can copy paste this code in, but basically, okay, there's a sawtooth and there's 5 of those sawtooths. Okay. These aren't even the same size, right? Again, as long as it's relatively correct, that's what I'm caring about. Make sense to everybody? Okay. But that's what we're looking for, just drawing a lot of stuff. Now, suppose I change the following thing. What makes the changes significant? So we've changed this. So we've added this thing over here called size. And notice here, instead of having a 10 over here, we have a size over here. Okay, what makes this change significant? In other words, what power or control does the programmer calling the function gain from the changes? And I don't want to say a wrong answer would be something along the lines of the programmer adds another variable, another argument to the output. Okay, right? Or now Ziggy Bob's drawing is now modified by the variable size. Those are incorrect answers. Instead, what I'm looking for is something along the lines of, oh, if this is 50, that means these sawtooths are bigger. Basically, the correct answer would be something along the lines of, now the programmer can control how big the sawtooths are. Make sense? And I put in 20 over here, so technically I would have to do like 20 of these things. Okay. All right. Draw the result of the turtle program below. You can draw a dot to represent a stamp. Yeah, this one's fun. Okay. Draw the result of the turtle program below. You can draw a dot to represent a stamp because normally you draw the picture of the turtle. Okay. So this is one of those patented. So this is good practice because, let's see. What did I do as the last question on the exam over here? Okay. My big hint for you and anyone who's going to be watching this later, okay? The hardest question on the exam is the last question. This question is most similar to the last question on the exam. The last question on the exam involves a nested loop like this. Make sense? So what do I mean? A nested loop. I mean this. See how it's nested? We've got a for loop, and inside the for loop, we've got another for loop. How many questions are on the exam? That's a great question. Let's open it up in a completely different program so I don't share it with everybody else again. Okay, open with Firefox. Yeah, so it's 14 pages, including, okay, so I'm going to go over that for, so that's as good a time enough to do it. Page 1, the score page. Page 2, notes, basically my don't panic page. Page 3, basic histories and concepts, which is the first page of questions on this one, right? Which is computer science, computer science is the study of computers, true or false, that page. Page 4 is evaluating those expressions, right? Like the ones that the ones with the PEMDAS, the order of operations. Next page after that is the page that deals with slices. The next page after that is here's some code. What is the output of it? Like what are the values of the variable? Next page after that, page 7, is 2 questions, each worth 5 points on for loops. One is what is the output of the code, and the other is asking you to write a for loop that prints out something. Page 8 of 14 is the questions we literally just went over. These ones over here that we went over that said, hey, here's the code. What changes do I get to make to this code? What power does this making the changes make? Okay. Page 9 is draw. No, you're not going to be able to have access to a computer. So this is you doing your best. Page 9 is here's some code that draws a shape. It is draw the output of this turtle program. It will not have a nested loop. It is worth 10 points. Page 10 is a program with some blank spots in the variables and the output. And I ask you to basically fill in the blank spots, like in the variables. Like I'll have a bob.forward, and then that part is what's inside the forward is blank. And then a bob.right turn and a bob.left turn, and those are blank. If I do that, yes, you will. If you do this practice exam, you'll be prepared for the extra exam, especially if you do the extra problems. Okay, finally, page 11 is the second to last question. The second to last question is, here is a picture. Here's picture A and here's picture B. Picture A is what the code currently does. Picture B is what I want. Here's the current code we have. Here's a blank spot for you to fill in the code that we need for you to draw to get from A to B, from picture A to picture B. Basically, and effectively, it's just simply do another, basically draw another line. And then finally, page 12 is actually draw the other, is that nested for loop that I warned was going to be the top. So technically there's 10 actual pages of content, and a lot of the turtle questions are 1 question per page. The last 2 pages are basically freebie points where they're like anonymous survey questions. We'll be tearing off that page, and basically here, the last question is 1 point, tear this page off as you hand your exam in. You'll automatically get credit for it. Use this page to make any suggestions of how you think this class might be changed to improve the rest of the semester. That is my standard end of exam question. Okay. Make sense? So there. So anyway, going back to this question is most like the hardest question on the exam, on the actual exam, because it's got that nested for loop. So the main thing here is that we need to recognize that we have two variables here. We have row and we have dot. So row will have the values. Row, for row and range. Row has the following values: 0, 1, 2, 3, 4. It will go through these values. Okay? We're going to start at 0. Row will start at 0. So let's go ahead and start at the top. Import turtle. Right. If we're asking you to write code and you forgot to import turtle, this will not come up. But if we did and you forgot to import turtle, I would not care. That's like one of those things that are easy for us to solve in programming. Once you realize, oh, I forgot it, you know. Next, Bob is equal to a turtle. Great. That's standard stuff. Bob.penup. That means we're not going to actually be drawing anything. The only thing that we'll be drawing are these stamps when we do them. Okay? So the stamps are the only part of it that we care about. For row in range 5. So we're going to start out with row is currently equal to 0 when we're in this block. For dot in range 0, row plus 1. So this for loop is only going to run row plus 1 times, 0 plus 1 times. Make sense? Now, also notice that we've got a variable here called dot. But if we actually look at the code, I don't ever actually use dot, so we don't have to keep track of it. So why would I call it dot? Why wouldn't I just leave it blank for blank in range? This is what we call a hint. I put those in the exam. I don't name my variables nonsense variables. And so you can reasonably guess that this, if you were to make the guess that this for loop is responsible for drawing the dots for your exam, then you're right. So anyway, for dot in range, row plus 1. So row's currently 0, right? So this will run 0 plus 1 times, which means this is going to run once. It will do a bob dot stamp and then move forward 50. And I'm going to just draw an X here to let us know that the turtle's there. Okay? Remember, the turtle by default is going in this direction by default. 50. Bob dot right 90. So let's find out what this code does over here. Bob dot right 90. So he was facing this way. Now he'll be facing this way. He is going to go forward 50. So he's going to go down right over here. So his position is right here right now. Okay. Bob dot right 90. So we're turning another right. Bob dot forward 50 times row plus 1. So 50 times, what is row? 0 plus 1, 1. 50 times Bob dot forward 50 times 1. So that just means move forward 50. Forward is this direction. Now we're here, right? We moved 50 this way. We turned, moved 50, 50. And now right 180. So we went this way, then 90, then another 90, and now 180. So 90 plus 90 plus 180, that's 360 degrees. So in other words, we are currently right here. That's our current position. And we are now facing this way. Okay. So we're currently where the X is, and we're currently facing the original direction. So we get to the end of this. Now we are now on row is equal to 1. Make sense? So we were at row is equal to 0. Now row is equal to 1. For dot in range, 1 plus 1. So now this is 2. So this loop will run twice. So the first thing we do is we do stamp. Then we move forward 50 to here. And now we execute this again because it says to do this twice. So we stamp and move forward 50. Make sense? So now we've done this for loop. So now we turn Bob will face this way now, face down, move forward. turn right. So he started this way, turned turned right, we turned right again. And then we're facing to the left now. Bob.forward 50 times row plus 1. 1 plus 1. So moving forward, 1 plus 1 is 2. 50 times 2 is equal to 100. Now, incidentally, when we moved forward, that was 50 plus 50. Now we're asking to go back 100. That we're asking to basically go in this direction, the same amount we went in this direction. It's almost as though I planned it out or something. So now we're here. Now update row to 3. Sorry, update row to 2. 2 plus 1 is equal to, oh, and yeah, and we're now, and don't forget the row equals 180, so we're facing this way. Anyway, now we're over here, row is equal to 2. 2 plus 1 is equal to 3. So now we put a stamp here, move forward, put a stamp, move forward, put a stamp, because we're doing it 3 times. And I think you see the pattern now, right? Because with a lot of these, once you get to the third iteration, you'll be able to figure out the pattern. Now, when we do these things, when I grade questions like this one, what I'm looking for is, hey, did you get the number of rows right? Is it off by 1? Did you get the number per row right? Did you, or did you do something like this? This is a common mistake I see in kind of stuff like that. Or did you just do this? Or this? Right? But what we're looking for is like the number. If you're off by 1, that's going to be 1 penalty. If you're off by if you drew too many, that's a different penalty, right? The only time the pen will be down is when it stamps. Yeah, stamp is its own kind of unique command that operates no matter, regardless of whether the pen's up or down. It's a belly flop. Okay, but I have a specific rubric, is the point, and I hand it out to whatever unfortunate victim is grading that one. It's typically me, and I just make sure that everything is applied fairly, like so that there is partial credit. Okay, and if you somehow mess up in a unique way I've never seen before, then congratulations, you're making me update my rubric for next time. But generally, I've seen enough of these exams that I'm usually able to predict the way students will mess up. All right. Complete the function so the turtle passed in as an argument draws the square. Each side of the square should be sidelong. We've done this before in class. That's why it's 3 points. 4 in range 4. How do I draw a square? I tell Bob to move forward side. FD is short for forward. That's in the Python code. But say it wasn't, okay? And you just got sick of writing forward so much, right? You could just simply put here FD is for forward. And guess what? I will honor that because while I'm a jerk about some things, I'm not a jerk about these kind of things, right? Make sense? So if you need a shorthand something, right, just note down what the shorthand is if it's not blindingly obvious. Okay, Bob.forward side, and then Bob.right 90. And that will get us to draw this. All right, so this question is, these next two pair of questions are definitely way harder than what I would put on the exam. Again, a lot of these practice questions are. I'll leave this one as an unsolved one, but you'll be able to work on it and use this original one as a basis for it, okay? So so this is my hint. Using the draw square function, write a turtle program that will give the shape below. You can create more functions if you wish. the picture. The turtle drew 4 squares. So the reason I put drew 4 squares is that this is not one of those, oh, see how smart you are. Only people with high IQs can count the right number of squares. Right? No, it's not that. This is the turtle drew 4 actual squares. That's the first one. Then he drew this other one. Then he drew this other one. Then he drew this other one. Okay. And somehow he ended up over here. Right. No, yeah, it's not clickbait. It's not a clickbait IQ test. He drew 4 squares. Okay. And so from that, we're able to extrapolate what's kind of going on, which is that the turtle, okay, how would I draw this if I'm not trying to do this clickbait kind of thing? And there's only 4 squares that got drawn. I draw the first square, right? And I always starting at the corner of the square, right? It's either going to be so I'm always going to start at the corner of the square, okay? And the way that I wrote my thing is I'm going to go forward and then right. All right, it doesn't matter how you basically adjust it based off of how you did your square function. So I'm going to go forward, then I'm going to go right. Okay? So boom, boom. Boom, boom, boom. Right? So it's going to be boom, 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 boom. So you always end up where you started. So I end up over here. So start and end over here. And then what I need to do is get the turtle over here to draw the same thing. In other words, and then I get the turtle over here to draw square again. Then I get the turtle over here to draw square again. And then I get lined up so I would do the next one if I wanted to. So in other words, 2 steps. Right? Each of this basically is the product of doing 2 steps repeatedly, which is draw a square, then get to the center of the square. Make sense? Make sense how that, everybody see how that's draw a square, then break down, get to the center of the square? Okay. So in other words, so let's go ahead and start that out, right? Oh, and I need to do this 4 times. So I'm going to just kind of assume 4 blank in range 4. Why 4? There's 4 squares. Oh no, I accidentally did a bracket over here. I don't care. I'm going to assume you just your pen messed up or something. That's fine. I don't care. Okay. So 4 blank in range. So what I'm going to do is the first thing I need to do is draw a square. Draw square. Right. Oh, right. I probably need to do import turtle. Import turtle. Bob is equal to Bob. Bob is equal to Bob. No, Bob is equal to turtle dot turtle. But if you forgot this, I'm not really going to be grading it that hard. Right. Again, the black magic is not what I care about. So first off over here, size is equal to, let's say 50. Draw square. I don't even need this actually. Draw square. 50. No, I'm sorry. Draw square. Bob. And let's just assume that this is, yeah, let's make this abstract. Bob. Size. So we're going to draw a circle, a square of whatever that size is. Sorry, a square of whatever size that is. Okay. Now what I have to do is that this would just simply, as I have it right now, do this 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So now what I want to do is I want to go 1, 2, 3, 4, get over here into the center. Okay. Okay. And now, so how do I get to the center? Okay. Now, the way I would get to the center is I need to move over, this way half the square and move this way half the square. Okay. So I need to move, so in other words, I can just kind of go forward, Bob dot forward, size divided by 2, Bob dot right, because I'm currently facing this way. Bob dot right, 90 degrees to face down again. And then Bob, so now I'm facing this way. Bob dot forward, size, divide by 2. I mean, if you wanted to show off how clever you were, I suppose you could do, I suppose you could like, you know, like go diagonal and calculate that out, but honestly, why bother? Okay. So size divide by 2. And now we're still facing this way. And for my next square, I want to be facing this way. So Bob dot left, $90. I did up there. I did up there. Size is equal to 50. I made it abstract so it was easier for me to write. It's easier for my brain, at least. If you want to hard code it, that's fine. If you want to hard code and say 50, 25, 25, that's fine. But it's easier for me to do. Okay. Now, what I've got over here will do the following. It will do 1, 2, 3, 4, move over here, move over here, 1, 2, 3, 4, move over here, move over here, 1, 2, 3, 4, 1, 2, 3, 4. Okay. So and if you're keen-eyed, you'll notice there's one thing different between my drawing and the correct drawing. So this would probably be like 2 points off on the exam or something like that. But the issue is that basically that it's hard to see a bit, but notice over here where I just simply go over and then I draw down and I do my thing and then I draw over this, but I'm drawing over the same line so it doesn't show up in the same way. So what we need to do to prevent this is Bob dot up to put the pen up while we are maneuvering into the next spot, and then Bob dot down when we're done. Okay. So in terms of these of all the problems that we're doing, notice that I put other ones. Yep, Bob dot up is the same as pen up. Yes. So if you want more practice on that one, okay, which I really think will help with your understanding on the exam, even though we don't have a question exactly like this, but I think it will really help. Doing problem 14, which is the 0-point extra practice, and I have a lot of extra practice on the exam near the end. I think this will greatly help. It's a very similar problem. Again, we are drawing 4 squares, 1, 2, so it's a bit of a more complex pattern. It's a bit harder to see how we get from A to B. Okay. Next one. Okay. Right. Okay. What is the output of this problem? There isn't something like this on the exam, but it's still good for the next part. Okay. This is one of those patented ones that are the reason I'm bringing it up is that other professors, Professor Fiore, I believe, still likes to ask these kind of classical computer science exam questions. These are the kinds of questions you would get in a lot of other universities. They're valuable, but they're also kind of nonsense because of the use of what we call metasyntactic variables, which are foo, bar, and baz. Different countries have different metasyntactical variables. These are ours because of a military background. Foo and bar and baz, I don't know where that comes from, but foo and bar comes from the military acronym FUBAR, which means something like fouled up beyond all recognition. But it's the military, so it's a bit harder, shall we say, but fouled up beyond all recognition. Similar acronyms include SNAFU, which is situation normal, all fouled up. Okay. Right. So anyway, so we've got, but again, foo and bar and like they don't have a meaning. They're like fnord, right? They're like fnord. They don't have a meaning. No, and that's a specific reference to certain things. There's no element you can grok, which actually also has its own meaning, right? If you can't really grok the meaning of something like that. But you kind of understood what I meant by grok. Okay, anyway, foo. So we've got three commands here. Foo will just print foo. Bar will call foo, print bar, and then call baz. And then baz will print baz and call foo. What a mess. Deliberately a mess. So we define our three commands and then we call them in order. So let's do command number one. Foo. Foo prints foo. Good. Next, bar. Okay, we call bar. What does bar do? Bar calls foo. Foo prints foo. So now we're here. Bar prints bar. Now we're here. Baz. Baz prints baz. And then it calls foo, which, whoops, I missed. Then it calls foo, which prints foo. And then baz is done. And then bar is done. And then finally, baz. Baz says print baz. Then we're here calling foo to print foo. So this becomes, our total answer is foo, foo, bar, baz, foo, baz, foo. Like I said, gibberish. The reason I have this question on here, though, is the next part, which is, if we change the following example, the above example to the following, what happens? Baz, foo, bar. So let's go ahead and put this on there. Let's go ahead and put this on there. Baz, foo, and then we change it to foo and then bar. Okay. Let's go through it. Foo calls foo. Sorry, foo prints foo. Bar says call foo. Print bar. Call baz. So let's go and do baz. Baz says print baz. Print foo, do foo, which prints foo, and then call bar. Bar says print foo. Bar says print bar. And then call baz. Baz says print ba. Call foo, and then go and do bar. Bar says print foo. Bar, do baz, which says baz, foo, and then bar says to do bar, which says print foo, right? And you can see where this is going, right? It's an infinite loop where basically we have this function calling this function, but this function calls this function. This is our first example of an infinite loop. Technically, this will most likely not go on forever. We'll get a stack overflow or something like that, which basically means that we have a runtime stack keeping track of where, which is something you'll learn about later on. But basically, long story short, is that we use something called a stack to keep track of where we are, and it gets filled up over time as we keep doing these nested calls. And so it will eventually overflow the capacity, whatever capacity has, and that's where we get that stack overflow error. But if you simply said an infinite loop, I'd take that answer. All right. Now, these two questions over here would be at the end. These are good practice questions. Professor Fiore loves these questions in 1068, and definitely you should know them for 1068. These are these are here because we need to learn an important lesson. Confundus and confundo, right? They're okay. The questions of this type will be earlier in the exam, right? Right here, they're at the very end, essentially. So what is the following code? Beware, it was intentionally made to confuse you. So, and we see that we have defined confundus, which does nonsense, okay, over here, okay? Then we have X, then we have 6, 8, 4, whatever. so we have x is equal to 6, y is equal to 8, z is equal to 4, and then we do confundus z x y, but then we have y x z over here. So this should tell you there's some real nonsense going on. And what is that nonsense? The nonsense is to teach you that these names don't actually matter. These names don't actually matter over here. What matters is position. Whatever's over here goes to here. Whatever's over here goes to here. And whatever's over here goes to here. So the point of confundus is to teach you that it's passed by position. The names outside, the names on the outside have no bearing to the names that are used inside functions. Make sense, everybody? So what should you do when you encounter this? A, 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 B, 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 C, C, C. Make sense to everybody what I just did there? Makes a lot easier. Well, all I did was change the variable names there because the X, Y, Z over here are different labels. They're overloaded labels than the variable names over there. So I just simply changed them to make it easier to read, if that makes any sense. And you can run the code and make the changes yourself to verify, right? But these variable names, right, were poorly chosen. Does that clarify things at all? All right. Well, this is going on for a bit longer than I wanted, so I'm going to keep going. Okay. What we have over here is we have x is equal to 6, y is equal to 8, and z is equal to 4. So now we have confundus zxy. So I'm going to go ahead and just 4, 6, and 8, right? I put them in the order that they appeared, not the new letter order, X, Y, Z, but it asked for ZXY. So I did 4, 6, 8, 4, 6, 8, 8. Okay. So now what happens is that these get passed in order, in the order that they are in the arguments over here. So Z goes to over here to where Y was, but we're going to just call it A to make things easier. X goes to X, Y goes to Y. In other words, 4, 6, 8, 4, 6, 8. A, B, C, 4, 6, 8. Make sense? Okay. And now, because I've done this, this next part becomes easier. B plus equals 1. So that says B is 6, so we're going to increase that to 7. Now A is equal to A minus B plus C. So A is equal to 4 minus 7 plus 8. So 4 minus 7 is -3 plus 8 is 5. So that will be A is 5. And then C, we don't have anything for that. So it should be CBA, which is 8, 7. So the output is CBA, so 8, 7, 5. Is that what the question gives us? I believe it should be. Okay. And just simply dump this into idle. Invalid syntax? What you talking about? Doesn't like me doing it like that. Oh, well, give me a second. File. I'm just double checking because I thought it was supposed to be in order, but been a while. Yeah, 876. It's 875. So I did it right. Awesome. All right. Now this other one is to emphasize this point, but in a much harder and much more painful way. Okay. So x is 17. We set up x is 17, y is 8, z is 2. Then we call confundo over here. So like we would do over here, confundo would do this, this, and this. Right? We'd pass in the variables like that. Right? We would do xyz, xyz to zyx, right? It would not go z to z, right? It would not go y to y. It would not go like this. That is not how that works. It goes like this. Now, this is a question that Professor Fiore loves to give in the next class, and it's one that I love as well. So the question is, what is this output? X is equal to x plus, so you'd think, okay, x is equal to 25, y squared, that's 64, and then z is equal to 2 mod 17, so big number, so that's 2, right? This is wrong. That is very wrong, actually. The answer involved doing no math whatsoever. The answer is 1782. The answer is this. So this is a trick. This is one. These are things that this is what we call a trick question. So first off, there's no print statement in here. We do these things. The trick is to remember this ABC trick that I just did over here. Okay, why? Because again, the variables over here inside the function have no bearing on the variables outside the function. Okay, makes sense? When we are passing in, why? When we are passing in a value over here, we are copying that value over. Okay, we are copying this value over. We are copying. Makes sense? We're making copies of this value. So anything we do to the copy doesn't affect what's going on over here. And it's easier to see when we just simply give them the labels ABC. So we do stuff, that stuff doesn't print out. And you can verify that for yourself. Okay. This is a bit more, this is subtler. And it's part of the reason why it's not actually going to be on the exam, that this particular thing won't be on the exam. An easier version of this will be, I believe. But this particular nonsense won't be on the exam because it's one of those things that you pick up as you program, but just know that other professors will test on that. Final question before we get to the practice of the other additional practice that I'll overview, but I'll leave this to you for literally additional practice. Okay, write a new function called print 3 limits. Again, there's so little code writing on the exam. I think about 30 points of the exam are actually writing code, only 10 of it, 25 points are writing code, 5 of which is actually says, here is prompt asking you to do code, no code given. The other 2 code writing bits is here's code already on the exam. I want you to fill in the blank spots. Okay. So there's very little like this on the exam. Write a new function called print 3 limit, which prints out all positive integers less than limit that are divisible by 3. Right. So this involves an if statement. So that's why, yeah, I'll go over how to do this, but it involves an if statement. So this is actually a terrible question. Actually, no, it's not a terrible question. We can do this without an if statement, which prints all positive integers less than limit that are divisible by 3. If limit is less than or equal to 0, print nothing. So what we want to do is we want to print out numbers in a range, or num in range. And this range is asking us to do something other than go 1 by 1. Okay, so it's a pretty good indication that we're going to need to do use all three parts of the range function, okay? But if I can adjust this range function correctly, there's nothing stopping me from just doing print for number in this range, print num. And the reason I'm confident of this is because it's asking for a pattern. All numbers that are divisible by 3. That's a pattern. The equal distance. That means I can do them. They're separated by 3s, right? So I can already fill at the end, right? I could, instead of doing, so I could do is I could print out 0, 3, oh, less than or equal to 0. So we're not even starting there. We're going to just simply do 3, 6, 9, 12, so on and so forth, right? So the first number in the sequence will be 3. Start at 3, go up to, and do we include that limit? Less than limit. No. Go up to, and don't include the limit. And that's actually it. For number in range 3 up to, but not including the limit, by 3s. And this will be 3. So if you put in 20, it'll go 3, 6, 8, sorry, 3, 6, 9, 12, 15, 18. And that's it. So this one, again, can be done with the range. You could have done this with an if statement, but honestly, again, none of the exam does not need an if statement. Okay. By the way, speaking of if statements, I know that the Thursday lecture was very unusual, and you may not have gotten a correct answer. That's fine. If you don't plan on doing a post interview with, a post session interview with the with Professor Ian or Professor McNeil, then please, I'll be happy to go over that problem with you. Okay, the blame Pope problem, but that just means you won't be able to do the post interview with them. But if once you do a post interview, if you want to know the correct answer, I'll be more than happy to provide it. Okay. All right. So these other questions, if you can do this problem, these two problems, 20 and 21, you are probably going to be more than able to do the exam if you can get those. If you can, like, if you struggle on this one and then figure it out and then are able to do this one, you're probably going to be in great shape for the exam. So, these other problems are just very good busy work, but these are just good busy work problems to help you get programming, but these specifically, right? If you can do 20 and 21, then that means you really get then you've really got a handle on for loops. Make sense? And these are tricky ones, right? But these are essentially harder versions of the second problem of homework of lab 4-5. Make sense? Harder versions of that. Project Euler problem 1, there's a website called Project Euler that's just simply solving the first problem on it. So which is asking you to print out the sum of all numbers less than 10,000 that are divisible by 3 or 5. Prints out the first n powers of 2. In other words, n numbers that are in this sequence: 2, 4, 8, 16, 32. 64 and so on. There's powers of 2 to the I, okay, where I is some number in the sequence. Write a method that takes in an integer. Method is just a fun way to say a function. So this is a bit left over from when this was a Java exam. So a method is another word for a function. There's actually a subtle difference, but not important right now. Write a function that takes in an integer and returns how many digits it has. So 523 would give me 3. You can print rather than returning. Write a method that takes an integer n and print out all the proper factors. All the factors of n aside from n. So in other words, like for the number 12, its proper factors are 1, I think 1's a proper factor, might not be, 2, I don't think it is, 2, 3, 4, and 6, right? Those are the proper factors. Yeah, aside from n. It's not the prime factors. It's basically all the numbers it's able to be divided by. The first n Fibonacci numbers. Sequence, print out the first n of the sequence that starts 0, 1, and it goes like this. 1, 2, 3, 5, 8, 13, 21, dot, 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 dot. Okay. Fibonacci is kind of interesting. It's named after a guy called whose alias is Fibonacci. It's almost completely like one. It's named after him, even though like there's almost certainly there's multiple instances of Indian mathematicians having discovered this centuries beforehand, but it's just the way naming works. But you see that in some functions like we saw with Leibniz, the Madhava Leibniz, how it's called that now. So anyway, it's a famous mathematical sequence, 0, 1, 1, where basically each term is the sum of the previous two terms. So 2 plus 1 is 3. So it's a good one. So figuring out how to print this out is a good exercise. Oof. All right, I've been going for almost 2 hours. David, you really did not need to be on here for this entire time, but it did help.
Just figured I'd be a pretty good moderator.
All right, so when I end this meeting, what's going to happen is that Zoom does its whole own format thing, and so it's going to render. It's going to take like 10 minutes or so to render. And once it's done rendering, I will upload it to YouTube, and then I will send out an announcement to that link so that you'll be able to review this if you need to. Before we sign off, are there any additional questions about this?
You guys can raise your hand, or if you guys want to definitely like talk. Like, I know there are some people that were having some issues with some of the questions. I think with like, are we all good when it comes down to like your fault, like your true or false?
Yeah. All right.
Oh, we got a couple.
Okay.
Emerson.
So yeah, percentage sign modulo. So Emerson. So mod just stands for remainder. The answer is no, but yes. You can totally, I know that's a terrible answer. The answer is for the purposes of this exam and understanding how modulo works in this kind of context, yes. Modulo just gives you the remainder. The answer is it's actually a fancy branch of mathematics that allows you to do mathematics in a limited kind of closed space. But that's like way where we don't need to be. Okay. So for the purposes of this, yes, it just stands for remainder. Just also be aware that if you decide to learn higher mathematics, you'll basically get a leg up on that and already kind of know how to do some easy math there. You already have access to the practice exam file. It was out in the announcements that I sent a while, like last week. Do you need to do the runestone readings before the exam? Need to for credit? No. I will be grading that stuff soon because midterm reports are due where I have to go for the U's and S's. By the way, about heads up, I give like 80% of the class an unsatisfactory report, like last semester, not because 80% of the class would fail, but because I give a warning like, oh, you're missing these kind of things. And this is the easiest way I have to let you know. But anyway, do you need to do the runestone in the sense for a grade? No. Do you need to would you advise doing the runestones readings? So you have to review for this? Yes. So for number 19, yes, it was print I, not print limit. I probably yeah, it was so to see if yes, if I did print limit, that was wrong. And thank you for catching that. Yeah, it's very hard to type and talk, to write and talk at the same time. It was print none. Yes, I didn't write. It was print I. Yeah. So the first one. Cam the man, my brain hurt. Yes, this happens often. And it is not unique to you, so don't worry. It hurt. it can be frustrating. Is it possible to change the day we take the exam? Depends on the reason. But in general, if you are sick, you can arrange with your TA to take it on another day. Or if you are, I have one student who's basically going to a Google thing on another, like they have a interview or something, or some career fair kind of thing, and so they're gonna take it on a different day. Or you can arrange if there's space to take it with a different TA.
Yeah, I think we have a couple, like I think we have one person that might be taking it, that's in my section, that's gonna be taking it with one of Monday's sections.
Yeah, so
So
this, sorry, somebody asked, when am I taking it? I'm just double checking that this is this year's semester syllabus I'm bringing in. Section
okay.
7, your exam is tomorrow at 11. So, um, good luck.
Section 7. So
7.
wait a minute, didn't you say it was something, were you saying Monday was
So sorry,
until
not tomorrow, Tuesday. Tuesday at 11. Tuesday.
gotcha.
Tuesday 11. Oh, my bad. I'm sorry. For some reason I'm feeling like, oh, today is Monday. It's not. It's today is Sunday. My bad. Okay. It is Tuesday. Yeah. So you've got the first batch. Tuesday's got the first batch. Monday, if you're in section 1 or 2, you do not have an exam tomorrow because you haven't had lab 5 yet. You have to do lab 5. Lab 6 is when you start it, and the lab 6 does start on Tuesday. Why is it like that? Why? Because the second Monday was a holiday. That's why. Are calculators allowed on the exam?
You really
No.
shouldn't need a
You
calculator.
wouldn't need a calculator. If you're worried about double checking the math or something, that's fine. Yes, cat.
Cat.
Very cute cat. I don't have one.
Oh wait, cat, where?
There
Oh,
was
oh,
one.
you meant mine.
Yeah, your cat.
Oh, yeah, he bites. He's nice, but he bites.
You don't need a calculator. Then the math will be doable by writing it down without even having to do like a change, to set up the it, we're it's the basic kind of math. I'm not testing your ability to do math. Understand that? I'm not testing your ability to do math. I'm testing your ability to uh basically I'm testing, do you know order of operations? That's a different question. Make sense?
Okay.
Um, right. I'm testing your ability to basically, do you understand how to do the remainder function? Okay.
Um, is there a specific chapter you
Are,
recommend for
are
the?
there any chapters I would recommend? Let me double check.
I think
Uh,
you were saying the exam covers all the way up to chapter 7.
I would definitely do chapter 7 and first taste of functions. Chapter 7, the turtle. So let me go ahead and double check.
Cool.
I would do, so if I had a target specifically, I would do chapter 5, 6, and 7, special attention to chapter 7, and then that subsection I have, first taste of functions, because just so I remember how that works.
hmm
Okay. But probably I would say 7's the most important chapter because that does use turtles. Because 7, just understanding the for loops and understanding turtles. This is the turtles and for loops exam. Okay, that's the bulk of the points.
Hey, Professor Rosen, did you talk to, I just want to make sure, because Tosuf, he's for number 19, it was death, 3 limit. Okay, he was talking about question
Yeah,
19.
I addressed that. Yeah.
Okay, cool.
Okay.
Okay.
All right. I'm going to stop recording now.
All right. So guys,